Because it's only the third time we've ever seen an interstellar object. And interstellar doesn't just mean Matthew McConaughey, it means something not from our solar system.
Remember that mysterious interstellar object that was discovered last week approaching the inner solar system? Well, scientists may have figured out what it is.
It's interstellar, it's between suns. And so this thing came from like beyond our solar system and is just passing through. It's only the third time we've ever seen something like that.
Is that why it's called 3I?
Yeah, because it's 3I, not 1I or 2I, it's 3I. That's exactly right. So it's exciting for that reason alone. And if it turns out to be a spacecraft, sure, I'll buy them lunch.
Harvard and NASA sound alarm. Alien object 3I/Atlas could strike Mars. The headlines were at first drowned in disbelief, then amplified by shock, and now repeated in tones of urgency across scientific circles worldwide. What astronomers once dismissed as a mere cometary flyby has transformed into one of the most perplexing and potentially dangerous cosmic events in recorded history. The object, designated 3I/Atlas, first detected on July 1st by Deep Sky Survey telescopes, was thought to be a harmless interstellar traveler, a visitor from beyond the solar system destined only to graze past Mars and vanish back into the dark void. Yet within weeks of observation, calculations began to shift. What was assumed to be predictable is now a riddle tightening with every hour of data. The numbers have changed, the trajectory is no longer static, and with each adjustment, the possibility of impact grows more real. Harvard astrophysicist Avi Loeb, already known for championing bold theories about interstellar visitors such as Oumuamua, has suggested in his latest papers that 3I/Atlas may not be natural at all. He argues that its motion displays hallmarks of guidance, intentional maneuvering that exceeds known physics of icy comets or rocky asteroids. NASA's Jet Propulsion Laboratory has confirmed irregularities too. Independent analysts across Europe, Russia, and Asia have run parallel models, and the convergence is startling. Instead of stabilizing, 3I/Atlas accelerates and course corrects, aligning with Mars' orbital plane in a way uncannily similar to a spacecraft executing burns for planetary approach. In the cold mathematics of celestial mechanics, comets followed the dictates of gravity and sublimation. They do not pulse in rhythms like a machine. They do not release gas in synchronized bursts every 17 minutes. They do not steadily close the gap on a planet's orbit as though chasing a target. And yet, that is exactly what has been recorded by observatories from Chile to Hawaii. Current velocity clocks in at nearly 87 kilometers per second relative to the Sun. That means the object is traveling the Earth-Moon distance in just over an hour. The Mars Reconnaissance Orbiter, tasked with capturing high-resolution imaging, detected an abnormal increase in brightness around the comet's coma. What appeared first as typical outgassing has escalated into spikes of ultraviolet energy unmatched by any known natural body. Instead of venting gases at random, 3I/Atlas seems to exhale with precision. Gas plumes orient in specific vectors that adjust its trajectory by micrometers per second, infinitesimal changes that compound over millions of kilometers into massive course shifts. Astronomers whisper of an object behaving like a guided missile, a phrase once relegated to science fiction, now uttered by serious researchers in hushed tones. The latest trajectory forecasts predict that by September 26, 2025, the comet will pass within a mere 1.95 million kilometers of Mars. On a cosmic scale, that is a razor's edge, close enough for the planet's gravity to tug the comet, alter its spin, and possibly nudge it closer still. If one more outburst of gas provides only a fraction more velocity, 10 kilometers per second, a trivial nudge compared to its present speed, the course will tip from near miss to direct collision. Such an impact, given the object's estimated mass of 10 billion tons and a metallic core hundreds of meters wide, would unleash the energy of millions of nuclear warheads. A crater 60 kilometers across, 5 kilometers deep, could scar Mars, ejecting debris into orbit and beyond, perhaps even into Earth's trajectory over decades. For planetary scientists, this is both terrifying and exhilarating, the chance to witness interstellar matter reshaping a world before our eyes. But for space agencies, it is a nightmare. NASA has already shifted communication satellites into contingency orbits, quietly preparing for a worst-case scenario. Leaked memos describe classified radar returns that indicate metallic echoes, not icy dust. Such echoes suggest density, alloys, and reflective structures impossible to reconcile with conventional cometary physics. One anonymous insider described the radar image as a hard shell encased in sacrificial ice, a description that resonates disturbingly with theories of alien craft disguised as natural objects. Meanwhile, European Space Agency probes have reported strange glints near Mars, 3 points of light arranged in triangular formation, persisting across multiple orbits. While initially attributed to instrument artifacts, repeated sightings undermine that dismissal. Could these be fragments ejected by 3I/Atlas or autonomous scouts deployed ahead of impact? The possibility now lurks in classified discussions between agencies, hidden from public press briefings but buzzing across encrypted scientist forums. Critics argue humanity may be panicking over nothing, that cometary physics remain poorly understood, that gas outbursts can mimic control when observed over limited windows. Yet counterarguments are weakening. Jets of sublimated ice are chaotic, irregular, subject to random sunlight exposures. They do not beat like a cosmic metronome in cycles precise enough to align with Mars' orbital plane, nor do they illuminate tails that split into green, needle-like beams pointing consistently toward a planet. Amateurs with high-powered lenses have begun posting images online, revealing eerie auroral radiance streaming from the comet's tail in rhythmic pulses. Each pulse appears to converge along Mars' trajectory. Some see natural beauty, others see deliberate targeting. In the weeks ahead, the global astronomy community prepares for unprecedented monitoring. Hubble, James Webb, ALMA, and even military radars are quietly pivoting resources. September 19 through 30 is forecast as the critical maneuvering window, when Atlas could deliver its final adjustments. If patterns persist, the comet could close the distance to under 50,000 kilometers, closer than Mars's moons Phobos and Deimos. At that proximity, one strong outburst would guarantee impact. And if it hits, Mars will not only be reshaped, but perhaps rewritten in history as the site of humanity's first encounter with an engineered interstellar messenger. In whispered conferences, the ultimate question looms larger each day. Is 3I/Atlas, a derelict probe drifting for millennia, finally reaching a destination coded in its system? Or is it an intentional emissary, a test by a civilization more advanced than we can imagine, gauging our awareness, our readiness, our fear? We cannot yet know. What is certain is that this is no ordinary comet, no passive rock obeying gravity's leash. It is something else, something stranger, and its path is tightening, meter by meter, toward a red planet already rich in myths of war and gods. Harvard's Avi Loeb has warned, if this object demonstrates control, it is the most important discovery in the history of science. NASA statements remain carefully neutral, but behind the scenes, planetary defense simulations run non-stop. The silence between official words and leaked whispers only deepens the sense that the world stands on the edge of revelation. And so we watch, we calculate, we wait. September approaches, and with it, a cosmic visitor unlike any we have ever faced. By mid-September, the skies above Earth will become the stage for humanity's most anxious vigil. Every major observatory, from ground-based arrays to orbital telescopes, will point their instruments at 3I Atlas, tracking every flicker of its tail, every pulse of gas vented into the void. Astronomers expect the object to enter its most active period between the 19th and 30th of September 2025, a window where its trajectory may lock into place. This window, barely a fortnight long, could decide whether Mars faces a catastrophic collision or a near miss by cosmic inches. The numbers are merciless. At a velocity of 57 kilometers per second relative to Mars during the final approach, even a grazing strike would unleash destruction beyond imagination. The energy released could vaporize cubic kilometers of Martian crust, lofting dust and debris high into the atmosphere, triggering planet-wide storms that might linger for decades. Spacecraft orbiting the Red Planet, from NASA's Mars Reconnaissance Orbiter to the European Space Agency's Mars Express, would face annihilation. Rovers on the surface, Perseverance, Curiosity, and China's Zhurong, would be buried or disabled, erasing decades of exploration in an instant. Yet what terrifies scientists most is not merely the impact energy, but the unnatural way 3I Atlas is approaching. Recent spectroscopy from Gemini South Observatory in Chile has detected emissions inconsistent with natural cometary gases. Instead of carbon dioxide and water vapor in random bursts, the object releases tightly timed jets of exotic molecules at precise intervals. Each pulse adds lateral thrust, as though small engines buried in the ice are steering its course. To planetary scientists, this is uncharted territory. To theorists of extraterrestrial technology, it is a vindication. Avi Loeb and his Harvard team argue the pattern resembles spacecraft reaction thrusters, short controlled bursts that shift trajectory without destabilizing spin. Critics dismiss this as overinterpretation, yet the data stubbornly repeats. 17-minute intervals, unbroken over weeks of observation. No natural process explains such precision. As if to underscore the mystery, amateur astronomers across the globe report strange visual anomalies. Long-exposure photography reveals 3 faint needle-like streams of light splitting from the tail, glowing with an eerie green radiance. Unlike random jets, these beams align toward Mars, converging in the planet's direction like navigational beacons. Some observers describe the sight as beautiful, others as terrifying, a comet painting a luminous path across the solar system toward its target. Governments, meanwhile, remain silent. NASA's official bulletins describe 3I Atlas as an interstellar comet under observation, assuring the public of no immediate danger. ESA issues carefully worded updates emphasizing scientific curiosity rather than risk. Yet leaked communications tell a different story. Memos from NASA's Planetary Defense Coordination Office, obtained by investigative journalists, describe 3I Atlas as a potential artificial interstellar object requiring constant tracking. They warn of high likelihood of trajectory modification events that cannot be explained by sublimation alone. Military interest has also sharpened. U.S. Space Command has diverted classified radars to probe the object's core, while Roscosmos has reportedly begun simulations for potential kinetic deflection attempts, despite acknowledging such efforts are futile given the comet's size and velocity. China's CNSA has announced an unscheduled deep space monitoring campaign without elaborating. Across agencies, whispers of planetary defense grow louder. Could humanity for the first time attempt to intercept and destroy an interstellar visitor? Experts caution against hubris. At 87 kilometers per second, 3I Atlas is untouchable by any missile or spacecraft we can launch. No planetary defense system exists for an object of this speed and mass. Any attempt would arrive too late, its trajectory altered only negligibly. The only defense humanity possesses now is knowledge, tracking, predicting, and preparing for the consequences of an impact. And those consequences may not be limited to Mars. Simulations suggest that debris blasted into space could intersect Earth's orbit within years or decades. Tiny fragments, perhaps carrying exotic materials or even engineered microbes, could drift inward. If 3I Atlas is artificial, as Loeb and others fear, what rides within that debris may not be inert dust, but technology or biology beyond our comprehension. This possibility has triggered quiet but intense meetings of international security councils. No nation will admit publicly to considering interstellar contamination, but emergency protocols originally designed for asteroid impact scenarios are being reviewed with new urgency. Spacecraft sterilization procedures, once aimed at preventing Earth microbes from contaminating Mars, now invert. Could Mars send something back if struck by an alien object? Amid this turmoil, another twist deepens the enigma. ESA's Mars Express has photographed 3 persistent glints in high Martian orbit, forming a triangular arrangement. They appear across multiple imaging passes, ruling out cosmic rays or lens flares. Analysts now consider the unthinkable, that these may be autonomous probes ejected by 3I Atlas during an earlier phase of approach. If so, humanity is not just watching a comet, it is observing an active mission unfolding in real time. Avi Loeb has urged a cross-analysis of these glints with archival data from Mars Reconnaissance Orbiter, suggesting that fragments may already lie on the Martian surface. If metallic shards are found with non-natural isotopic ratios, it would confirm beyond doubt that 3I Atlas is engineered. Such confirmation would mark the single most significant scientific discovery in history, surpassing every probe, rover, and telescope humanity has launched. Yet time is slipping away. By September 26th, the object will cross Mars's orbital path. Between now and then, the pulses may tighten their rhythm, steering the object into an unavoidable collision, or perhaps into a deliberate near miss, close enough to release